Logarithms, more properties. Properties for expanding logarithmic expressions. So if we have m and n, capital M and capital N, that are both greater than 0, what we're going to do is we're going to be taking the log of them, right? X has to be greater than 0, so these are taking the place of x in our other properties that we talked about. So if we multiply two things inside of a logarithm, then we can add the two logs. And this follows our exponent rule, right? If you multiply like bases, you add the exponents. Well, logarithms are exponents, right? They're the same thing. So we're going to add the two logs together. Now, notice it's not m plus n. We don't have a rule for the log of add two things together. We have a rule for log of multiply two things, and it is add, right? A log plus a log. Not a log of one thing plus something else. Two logs added together. That's the product rule. The quotient rule, log of m over n, log m minus log n. Again, for exponents, what do we do if we divide like bases? We subtract the exponents. That's what's going on here. Notice it is the division inside a single logarithm. You get a log minus another log. If you have it written as a subtraction, it's got to be two separate logs or you can't do anything with it. There's not a rule for that. So here, log base b of m to the p power, the power comes out front, right? So it's out front now. And that's your power rule. So a power to a power, right, in exponent, power to a power means multiply the exponents. So here we're taking that power, that exponent p, and multiplying it by the log because remember, logarithms are exponents. All right. So then, look, now we're going to talk about the properties for condensing logarithmic expressions. Again, capital M and capital N are both greater than 0. And you know what we're going to do? Go the other direction. We literally just took the two logs added together and put them on the left and said that equals a log of multiply those two things together. We just go in the other direction for condensing. It's the same exact property, just turned around. So the quotient rule, same thing, turned around, right? Subtracting the two logs on the left equals the division of m and n inside a log on the right. And then here we're taking the power and we're moving it up here, right? To right here. So same three rules, product, quotient, power, same three properties, just turn them around, okay? So the way that I remember these, if it's in the top, it's positive, and top by top, I mean numerator. I know that's not kosher to say that it's so, it's in the top or whatever, right? It's not all proper. But anyway, bottom, denominator, negative, top, positive, numerator, positive, and the powers come out front. Those are the three things I remember, and I can go either direction. If it's out front, make it a power. If it's a minus, put it in the bottom. If it's a plus, put it in the top. That's what I remember. Okay, and again, top is numerator, bottom is denominator. And the one other property I want to talk about in this video is the change of base property. The change of base property for m greater than 0. Log base b of capital M equals, notice I'm changing from base b to base a, so some other base. All right, log base b of m equals log base a of m over log base a of b. All right. So log base a of m over log base a of b. The reason we do this, okay, the reason I teach this is you need to know it for one, but for another, the calculators that my class currently uses only have two log buttons. Okay, the school I'm at requires them to only use a certain level of calculator, and it only has log and ln. It has common log and it has natural log. It does not let you put in log base 6 or log base 12 or log base whatever, like some calculators do. It only does those two things. So if they can't change the base, they can't evaluate something like these next two problems, log base 6 of 17 if they need to, right? So what we want to do is we want to change, I want to use common logs or natural logs to evaluate to 4 decimal places, all right? So what I want to do is I want to rewrite this as log of 17, right? The m goes up here and then b goes in the denominator, right? So log base 17 over log of 17 over log of 6. Now, I don't ever do log, right? Part of that's because one of my professors in college told me there was only one log and it was the ln. No other log mattered, right? Now, he was being a little facetious with that, but still. So, but also, some people say we're lazy, but mathematicians, we like to write down less stuff. I call it efficient. People call it lazy. Ln is 2 letters and log is 3 letters. So when I do this, I don't ever use log. When I do this, I say this is going to be the ln of 17 over the ln of 6. That's just what I do, right? I do the ln of 17 over the ln of 6. And then, if I find, and I'm going to write these down, but really you find this in your calculator all at once. Actually, I'm not going to write it. I'm just going to say the ln of 17, the ln of 17 is 2.83. with a bunch of other stuff after it. I'm going to divide that by the ln of 6, which is 1.791759, blah, 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 blah. All right. When I divide those two things, then I end up with 1.58, and then it's 1, and then it's a 2, 4, and the 4 says leave the 2 where it is. So the 4 decimal places, 1.5812 is the natural log of 17 over the natural log of 6, which is the log base 6 of 17. That means 6 to what power is 17? Right, I couldn't really solve that. If I rewrote this, if I said 6 to the x equals 17, I can't write 17 as 6 to a power, right? So that's why I need logarithms here to approximate this. So the next one, same deal. I can't do 16 to some power is 57.2. So let's figure out what it's going to be. So I'm going to rewrite this as, and again, it works with log. I just always use ln myself, but you can write down either one. Either one works. So you try log, and see if you get the same thing. ln of, I don't like the way I wrote that, 57.2. Not that this is much better. Over the ln of 16. So the ln of 57.2 is something like 4.04655. And then I'm going to divide that by the ln of 16. And the ln of 16 is 2.77258887. All right. And if I divide all of that together, I get 1.459. And my next two digits are 48. My next two digits are 48. This 8 says take that 4 and go up to 5, right? So that's going to be 5. So 1.4595 is log base 16 of 57.2. We do the log of 57.2 over the log of 16. And I know I said log, all right? It goes back to that habit of that professor I had. He just said log. But natural log is what I used. Natural log of 57.2 over natural log of 16. Or you could have used log. You would get the same answer, right? You would get the same answer either way. All right? So here, let's expand. Let's expand and let's simplify where we can, but let's not plug in a calculator and get a decimal here. Let's just write down what we have. Log base 8 of 8 over x. So if I expand these, remember anything in the top is positive. So this is going to be log base 8 of 8, and I mean it's positive here. So first term positive, we don't write plus. It's understood. And then anything in the bottom is negative. So this logarithm is negative minus log base 8 of x. Every one of these is log base 8. Every one of these is log base 8. It's just the log base 8 of 8 comes from the numerator, the top, so it's positive. Log base 8 of x comes from the bottom, the denominator, so it's negative. That's where the negative comes from. And then that simplification piece, look at this right here. If these things match, log base b of b, that's 1. So this is 1 minus log base 8 of x. Can I simplify that? No. The way I know is I can't write x as 8 to a power because I don't know what x is. So I have to leave it 1 minus log base 8 of x. So then the ln of e to the fourth divided by 7. The ln of e to the fourth divided by 7. So here, I'm going to rewrite this as, again, the ln of the numerator. And if you want to, you could say, hey, the power comes out front, because I actually do that all at once. I say, hey, the power comes out front, ln of e minus ln of 7. Why do I put minus ln of 7? Because the 7 is in the bottom, the denominator, it's negative. Powers come out front, top's positive, bottom's negative. That's what I remember every time. So I don't do this in multiple steps. I do this in one step. Whether I'm expanding or condensing, I do it in one step. Powers come out front, everything in the top plus, everything in the bottom minus. I'm done. Top's numerator, bottom's denominator. All right. Now here I'm not done only because I have something that simplifies. Ln of e. We know from our properties that the ln of e just becomes 1. So this is 4 times 1, which is 4 minus the ln of 7. We can't simplify ln of 7 because we cannot write 7 as e to a power. We can get a decimal approximation, but we're not asked to do that here. We just want to expand it. All right? So we're going to leave it 4 minus the ln of 7. So here, expand log base 5 of x to the fourth y over w squared. Again, every time I write down log, it's going to be log base 5. And here I have 1, 2, 3 things, right? So I'm going to have 3 log base 5s. 2 of them are going to be positive because I have 2 positive factors up here and one positive one factor down there. I'm sorry, the denominator is just going to be negative, a negative logarithm. Now, note, if this was x to the fourth, if there was a plus here, I couldn't do what I'm about to do, but there's no plus there. These are multiplied. So I'm putting my rules together. The power comes out front, so 4 log base 5 of what? X, because the x to the fourth was all together. That 4 applied to the x. That's why the 4 is on the log x. Okay? Log base 5 of x. And then I add log base 5 of y. Why is there no number right here? Because y didn't have a power to bring out. It's just a 1. Just leave it. Right? And why is it plus? Because the y is in the top, the numerator. This is plus because the y is up here. If the y had been in the bottom, it'd be minus. Now I say minus because the w is in the bottom, right? Minus the log base 5 of w, but I don't leave the squared. What do I do with the 2? I put it out front. Right? Just like I brought the 4 out front. Powers go out front. Everything that's positive goes in the top, or everything in the top is positive. Everything in the bottom is negative. So now I've rewritten this. This would be 1, 2, 3, probably 3 steps in a book. 3 steps properly. But again, I remember those 3 rules as top positive, bottom negative, powers out front. And I just write it down. I take it each one at a time, one thing at a time. But I do have to identify what I have here. So the next one, ln of all this business, right? ln of x to the fourth times the square root of x squared plus 3 over x minus 6 in parentheses to the fifth. How many ln's do I have? Be careful here. I have 1, and then this is all one thing. You don't have a rule for plus up here, and it's under a radical. So that's all one ln, and this is all one ln. We don't have a rule for x minus 6. We can't break that up. So this is just 3 ln's again. It's not very much different than the one above it, except it looks a lot different. All right, so it's 3 ln's. So it's going to be what? It's going to be ln of x, and x is to the what power? 4, so it comes out front. The 4 comes out front. So 4 ln of x because the fourth power applied to the x. And then we add ln, and notice I left space here on purpose because I have a power even though it's hidden. ln of, and if you have more than one term, x squared plus 3. If you're taking the log of more than one term, you must put it in parentheses. You cannot do this. You can't do this. ln of x squared plus 3. You just wrote down ln of x squared and then plus 3 separately. No, you cannot do that. You must put that on there if you want ln of x squared plus 3. Okay? X squared plus 3 to be taken inside the ln, all of it. All right? But look, what is the square root? The square root is what power? The square root of x equals x to the 1/2 power. Remember that? So that means that this whole thing is to the what? 1/2. And here's where you definitely don't want to use a slanted fraction because you would really be messing stuff all up. Don't no slanted fractions here, okay? Without a parentheses in it, you'd be messing everything up. All right, so then 1/2 and then ln of x squared plus 3, and then that takes care of everything up here. So we don't have anything else as plus. This is all what? Minus. So now we have minus the ln, and again, it's more than one term. So x minus 6, that's non-negotiable. The x minus 6 must go in parentheses. It's got to happen. All right, but what's my exponent? My power, 5. So where does my 5 go? In front of my ln. So minus 5 ln of x minus 6. Again, everything's positives in the top, everything negatives in the bottom, and then my powers come out front. All right? And so there we have expanded our logarithm here. All right? We have expanded our logarithm here. So let's look at this one. ln of x, y to the fifth, over w to the fourth, z to the ninth. All right? So, again, I have, well, let's see how many things I have. I have 1, 2, 3, 4. And it's important to know that because what is the fifth power associated with here? Is the fifth power on the x or the y or both? It's just on the y. The y is only the only thing raised to the fifth power. The x does not have an exponent. So what students are tempted to do is write 5 ln of x, but this is simply ln of x and then plus, because this is up top, but the fifth power goes to the y. So it's ln of y and then times 5, okay? ln of y times 5. And then I come back and say what? Minus, because now it's in the bottom, it's in the denominator, ln of w, but wait a minute, w has what power? 4. And then also minus, right? Why is this next ln of z negative? Because it's in the denominator. Right, so what books are going to do is go minus ln of w to the fourth plus ln of z to the ninth. And then they're going to bring the powers out front, and then they're going to distribute the negative. They're going to do this problem here in a textbook or technically done with every step shown is going to be 1, 2, 3, 4, 4, at least 4 steps, maybe more than 4 steps, maybe 5 steps. Okay, it's going to be a ton of steps. All right, so forgive me, there's something on my screen, so I have to wipe it off there. All right. So condense to a single logarithm with a coefficient 1. Single logarithm with a coefficient 1. So I don't want 2 logs, I want 1 log. So that means anything that's out front's got to come up and be a power, which here there's none. And then if I add 2 logs, what do? This is the same thing as the log of 5 times 2, which is the log of what? 10. But wait a minute, what's the understood base here? 10. So if the base is matched, log of 10, our properties told us is just 1, right? The key there, though, is it's 5 times 2, and then the log of 10 simplifies to 1. All right? I will tell you this. My favorite problem I've done so far is this one up here, okay? Of all these logarithms, that's my favorite one, all right? It's got all the stuff in it. We got to worry about where the 5 is. It's got 2 things in the denominator that have to be negative, all right? That's my favorite one. This one, that I just did down here, it's okay, but I'm not a big fan of simplifying when you get done because we've practiced simplifying already, and now we're condensing these things or whatnot. So let's keep condensing, and if we can simplify, we will. So just be on the lookout for that. All right, so log x plus 7 log y. Again, the bases have to be the same to do this, by the way. We can't have like log base 2 and log base 3 and put them together. They have to be the same. Well, they are. They're understood 10 here. So these are added. So do I have a fraction right here? Is there a fraction? Nope. No fraction. So whenever I get ready to write this, I just say log, and then I'm going to put all the stuff in parentheses here that I have. I have an x. And then what do I do with this 7? It's my power, right? So this is x times y to the 7. Don't put a plus there. No plus, right? The plus is here of 2 logarithms means multiply the 2 things here, okay? It goes back to that product rule. So the log of x, y to the 7th power is condensed into a single logarithm with a coefficient of 1 right there in front of the log, right? So the next one, are the bases the same on the next one? Yes, because they're all what? ln. So here, do I have a fraction on this one? Yes, I have a fraction. How do I know? Because of the minus sign. The minus sign tells me I have a bottom, a denominator. So when I get ready to rewrite this, I'm going to have ln of, and I'm going to have a fraction. I'm going to put it in parentheses. I got a fraction. So let's just take one term at a time. Where does this go? It goes in the top because it's positive and it's y to what power? The 4th. If I add, I do not put a plus here, right? I'm simply multiplying. So now my next term is this. It goes in the top. Really, I think about that as my next term. And this tells me top, okay? So then I do what with the 8? I bring it up to the exponent. So this is x to the 8th power. These things are multiplied because you added 2 logs, okay? You added 2 logs over here. They're multiplied. Y to the 4th, x to the 8th. And then this goes in the bottom because of the minus, and it's w to the what power? 3rd, because this 3 goes up here, okay? So y to the 4th, x to the 8th over w to the 3rd, and that's all inside a natural log. If you wrote it this way, if you were careful and wrote it really nice, look, the thing that the parentheses does is remove any doubt. If you don't put the parentheses there, then depending on how you wrote it and where you put your fraction and how you wrote you could have all kind of crazy stuff going on there. So just put that in parentheses to make sure. Just put that in parentheses to make sure, and then there's no doubt. So when your teacher grades it, whoever their teacher is, they go, oh, there's no doubt what they're taking the log of. Good job. Good job. So here, I left the whole page. This is craziness here, okay? So log base 4 of x minus 3 plus 5 log base 4 of y minus 3 log base 4 of x plus 2 minus log base 4 of w. That means out of breath reading that one. Okay? Are they all the same base? Log base 4. Yes. So that means I can write this as a single logarithm base what? 4. And I'm not going to do it. You could do this thing in 3, 4, 5, 6 steps, putting all this stuff together one thing at a time. Everything that's positive goes where? In the top, the numerator. Everything that's negative goes where? In the bottom, the denominator. And what happens to the numbers out front? They become my exponents are my powers, right? So here, do I have a fraction? Yes. All I need is one negative, but here's another negative, which means I got more than one thing in the bottom. So I have a fraction, and then I'm going to have parentheses here, and I'm making it big because I have all kind of stuff going on here, okay? Remember, there's not a rule to break this up. This has to stay x minus 3. So x minus 3, this is positive, so it goes where? In the top, there's no number to make a power, so just x minus 3. And then plus, this right here is positive, so the y goes in the numerator, the top, and the 5 becomes the power. Now, it looks a little funny to write y to the 5th after the x minus 3. So if you wanted to say, Mr. Guess, I don't like that at all. I want to put my parentheses last because that's just typically what we do. Then we can say, okay, this is x minus 3 and then y to the 5th. So you just recognize that and you say, you know what, I just want to do that way. All right? And then minus, this goes where? In the bottom. The minus is put in the bottom, in the denominator. So then it's going to be x plus 2 to the what power? The third power, right? That goes as the exponent. And then this is also in the bottom, right? Negative says put it in the bottom. So the w, and again, I'm going to put the w in front of my parentheses just because it looks better that way. That's what we're used to. But if you don't, if it's after it, it's the same thing. It doesn't matter, okay? So here, there's my single logarithm with coefficient 1. So yes, I put that together one at a time. That takes several steps to do. Positive numerator, negative denominator, powers out front. The numbers out front become powers, and I'm done. It's just what I do. All right. So here, 1/3. Oh, look at this. This has parentheses. So really, I should do this first and then apply the 1/3 later, right? So let's do that. This is 1/3, and then it's ln of what? Ln of, do I have a fraction? Yep, I got a fraction. What goes in the top? X. What about the bottom? Y. And I'm going to put that in parentheses to make sure. So this is going to be, this now becomes the power. It's out front. It's multiplied. These parentheses here are extra, but I wrote them anyway. So if you want to say, okay, that's 1/3 ln of x over y. So then this becomes what? Ln of the x over y to the 1/3 power, which can also be written as ln of the cube root of x over y. So if you were in my class, I would take this answer or this answer. I don't want the 1/3 out front because it says coefficient of 1 out there, so the 1/3 would not be following the directions there. All right? So, as I do this here, I got one more that I want to do here. I believe this is the last one. So all these are log base 7. So I can combine them. Do I have a fraction? Yes, because I have minuses here, right? I have a fraction here, so I'm going to say this is going to be the log base 7 of, I don't like my 7, log base 7 of what? Well, x plus 4 and 1/2 is positive. That's in the top, the numerator. So x plus 4, and I'm going to do an extra step here that I may not do. I know what 1/2 means. It means square root, but I'm going to write it this way right now. This goes in the bottom or denominator. It's w to the what power? 5th. This goes in the denominator, so it's going to be y plus, y is in the denominator because it's negative. That says go in the bottom. Y plus 2 to the what power? 1/3 power. And then this goes in the top, the numerator, x to the what power? X to the 6th. And then I don't like the x to the 6th. I'm going to move it up here, and then I don't like my 1/2 and 1/3 business. So I'm just going to rewrite this as log base 7 of x to the 6th times x plus 4. Oops. I said I was going to write it a different way, didn't I? So I want to write it as the square root of x plus 4 over w to the 5th, and then the cube root of y plus 2. And I'm going to put all this in parentheses so there's no doubt what I'm taking the log of. All right? No doubt what I'm taking the log of. So that one was kind of long and complicated, but I wanted to show you one that was a little crazy and had roots in it and all kind of stuff, radicals and all kind of crazy stuff. So I hope this helps out with your logarithms and more properties, the expanding and condensing.